Have you ever looked up during a shower and noticed this and wondered why there is white solid all over your shower head when it seems like nothing but liquid is coming out? That is the evidence of hard water. Particularly, it's probably mostly calcium ions that have precipitated out with carbonate ions. Of course, there are several combinations that could cause that. In a region like ours, we expect the water to be hard. If the water did not contain all these dissolved ions, it would be considered soft water. And you can get water softeners that remove these ions so it doesn't precipitate out like that. Is water hardness just an issue for your shower head? Well, if it's precipitating out on the shower head, guess what it's also doing on your body and in your hair as you're taking a shower. So it typically means you're going to need more soap in order to not only wash out the stuff that you're trying to wash off your body, but to also wash off the solid that's going to form. And this is also what causes what we call soap scum, and that's why if you used a detergent, you would not get that, because detergent has items included in it that take the solid out. On the other hand, detergents aren't all that great for your skin. So we use soaps for our body, and you obviously need a lot of soap then to not only clean your body, but to also get rid of any solid that's forming as you're cleaning your body. This is our first of many guided inquiry labs. What does that mean? That means I'm not going to tell you the steps you need to take in order to do this lab. You will have to figure that out first before you get started. The good news is it is a easy, simple, only a few steps kind of lab to do that. It does mean I'm going to tell you what I want you to do. I want you to determine how hard the tap water is using gravimetric analysis. Gravimetric, like gravity, is talking about weight. Now technically it should be mass. We'll use our balance, our electronic scale there to determine the mass, but in chemistry, mass and weight, although they're not the same thing, we just don't care so much. In physics class, you better not get those two confused. That's a huge difference in physics class. The main thing I want to go over in this video is how to set up for the gravimetric analysis, because we're going to use some equipment that you may have never used before, and that's perfectly fine. Here's how you're going to use it. We have a sample of tap water, and we have a sample of sodium carbonate. We know we've measured how much sodium carbonate, we've measured how much tap water. We don't know the molarity of the calcium ions in there. We will know the molarity of the carbonate ions in there because you have measured and can therefore calculate what the molarity is there. When we mix the two, we're going to get a precipitate forming that is going to be calcium carbonate. The sodium will stay soluble. The chlorine that the calcium chloride probably started as is going to stay soluble. It is the calcium carbonate that's going to precipitate out. For the sake of this video, I did a different compound, and so you will not get this yellowish compound. Yours will be completely white. But it does show up on video better to have a colored compound like this. So I have formed a precipitate. To do gravimetric analysis, I need to know the mass of that precipitate. How can I get the precipitate out of there to find the mass of it? I hope you said filter it, because that would be correct. We have filter paper, yay! So I'm going to use the filter paper, I'm going to get solid on there, and I would mass it. Oh, wait a minute. If I put solid into my filter paper and I masked it, that would be the mass of the filter paper and the solid. That won't quite work. What should I do first? Right, take the dry filter paper, mask the dry filter paper first, then filter to get the mass on it, and then once it's dry again, put it on the balance again, and then you can do calculation, not a measurement, a calculation to determine the mass of just the solid that's on the filter paper. To speed up the process, because we could totally do it like we did in pre-AP, stick this in the funnel, take our time to pour through and filter it. We could do that, but to speed things up, we're going to use vacuum filtration. Doesn't that sound fun? All right, so for vacuum filtration, we're going to take an aspirator tip. I have one of these for each faucet in the room, so your groups are going to be limited to how many faucets I have. This screws into the end of the faucet. Now screw gently and carefully, don't strip the threads. If you're twisting and it's not sticking, twist the other way, right? And you don't need to crank this down and make it super tight or anything. Just turn it till it stops turning and you're good. What's going to happen is as you turn on the water, you're like, well, la-di-da, the water still comes out. Yes, the water is still coming out, but now it's pulling air in through this valve here. So we're going to take a hose, and we're going to have our hose on There we go. Makes a really nice seal. We're going to have our hose attached to that jet so that now we're getting vacuum. We're actually getting air pulled through here. And if you were to put your finger on it, you could actually feel that there's some pulling of the air through there. It's going to pull on your finger a little. It's not like my finger's going to get sucked inside the tube or anything. It's not pulling that hard. Truly, though, the faster you turn this on, the more it's going to pull the air through. So you do want pretty good volume of water coming through when you're ready. All right, but for right now, you've got the hose, which is a thick tubing so that it can withstand the pressure, and you're going to put it on a flask that has a spout on it as well. And if you find it difficult to get this on, you could certainly wet the inside just a little bit, and it doesn't have to go all the way up through. All right, it just has to be on. If it popped off, you could put it back on again later. All right, so this is on our flask. It is ready to pull air if I turn it on the water. It is actively pulling air through the flask. Now comes our fun funnel. The funnel with the rubber stopper goes in the top, and as we turn on the water, air will get pulled through these holes. Remember that paper that we masked? It's going to go right there. The paper is bought so that it specifically fits the inside of the funnel. This is a Buckner funnel, by the way. So it fits the inside perfectly. You have to match your paper with your funnel. And if I were to turn on the water now, I'm going to get active air being pulled through the filter paper into the flask and then through the faucet. Right? This is where I'm going to put the precipitate. So come on over so you can get a look inside the funnel. So there's the inside of the funnel. All right, it's going to get noisy. That's okay. I'm going to turn on the water very, very fast. I can actually hear vacuum from here. You may not be able to, but that's okay. Now I'm still going to slowly and carefully pour my liquid into the filter paper, into the funnel, and through. And I'm going to do this in a way that only gets it as close to the center as possible. You do not want it reaching the ends of the filter paper itself. That might cause the liquid to wrap around the ends and then not get filtered. So you can see, okay, you can see as my filter paper wets that it's also going to be pulling the liquid through those holes into the flask. Okay? And I'm going to slowly and carefully pour into the center and get it to filter. All right, so you would pour through all of this. Now I want to scoot this back for a moment. Okay, notice how we're getting liquid down through the flask. Hopefully that's none of your precipitate and all of your filtrate is going through there. And I'm going to slowly, now you can imagine you're like, well, I'm pouring slowly. Yeah, you're pouring slowly, but it's certainly going a lot faster than if you had to pour it into a funnel and wait for it to filter that way. Okay, so pretend that I have finished filtering all of that. Okay, what would I do? Well, I would obviously turn off the water, and I would clean out the flask before putting it away. What do I have in the funnel? I have my wet filter paper with the precipitate on it. And again, your precipitate is going to be white. You might not actually see the precipitate, but it will be there. All right. I need the mass of the precipitate, which means I need the mass of the filter paper and precipitate. Easy enough to do, right? Just put it over here on the balance and get the mass. Oh wait, no. What also is on this paper? It's filter paper, precipitate, and water. There is moisture still on this paper. So what do we need to do to this paper before we can find our final mass? We need to let it dry. If we had all the equipment we could ever ask for, we would have drying ovens. You could slide this in a drying oven, and a few minutes later all the water has been heated and evaporated, and we're good to go. We don't have drying ovens. What about over a Bunsen burner flame? You don't want to chance that because you could just as easily burn through the paper as you could heat away the moisture. So the safest thing to do, we're going to take this and we're just going to put it in the windowsill until tomorrow. Let it dry overnight. By tomorrow it will be dry. Does that possibly give time for contaminants to get onto our filter paper or for some of this to blow away? Yes, but we're going to assume that that is a negligible amount of change there. Although if you're putting it under an air conditioner vent or a place like that, it might be a noticeable amount. So you want to pick your location carefully. Our windowsill should be nice and calm for it to sit there and dry. Once it is dried in the windowsill, then you take your final mass measurement, and then this can just simply be thrown away, and you're ready then to calculate the mass of your solid. From there you can use the molar mass to find the moles of the solid, and from there you use stoichiometry to find the molarity of the calcium ions in the tap water. And then I have a chart for you that turns it to parts per million, and you compare and tell me what the hardness level of our tap water is. All right, so that's our water hardness lab. I wanted especially to introduce you to the new equipment. That is the vacuum filtration. Okay, going to speed things up for us. Too bad we don't have the drying ovens to really speed it up for us, but that's all right. Better that we take 5 minutes slowly pouring it through this than to take 20 minutes letting it go drip, drip, drip the old-fashioned way. All right, so good luck. This is what's expected of you tomorrow.